Hi, my name's Annie Bell and I go to PCS. I'm here at the Natatorium in Hattiesburg, Mississippi to do my work sample. For my work sample today, I'm going to apply physics to swimming. Swimming was a big part of my life for a long time. I used to train hours before and after school, sometimes 8,000 yards per day. So it's very important to me. For my work sample, I'm going to apply Newton's 3 laws of physics directly to swimming. To demonstrate these principles is my friend Griffin. He's kindly volunteered to help me out today in his zebra print Speedo. So stand back and here we go. Newton's first law of motion is the law of inertia. He states an object at rest stays at rest unless acted upon by an outside force, and an object in motion stays in motion unless acted upon by an outside force. Resistance is the opposing force in water, much like the force of friction. Combating resistance is the main obstacle that a swimmer faces. Water is 1,000 times more resistant than air, and 91% of a swimmer's energy is lost through drag. Therefore, a swimmer needs to maximize his streamline and reduce the surface area of the human body traveling through the water. Reducing the surface area will decrease resistance and therefore increase the swimmer's velocity. Griffin will demonstrate this by first pushing off the wall with his arms spread apart, and later he will come back and push off of the wall with his arms in the position that swimmers call streamline. As you can see, whenever Griffin pushes off of the wall with his arms spread apart, he doesn't go very far. This is because his body has a greater surface area and he has more resistance combating him. When Griffin comes back and pushes off of the wall with his arms in streamline, he easily glides through the water and goes twice as far as before. This is because his body is in a hydrodynamic shape and he has less resistance combating him.
Hello again to all my friends, together we can play some rock and roll. Hello again to all my friends, together we can play some rock and roll. Hello again to all my friends, together we can play some rock and roll.
Newton's second law is force equals mass times acceleration. This explains why some people can swim faster than others. For example, if 2 people push off of the wall, and one is using more force than another, and they have the same mass, the person using more force will easily go farther than the other. Likewise, if 2 people are diving off of the blocks, and one has a greater muscle mass than another, and the 2 travel at the same speed, the one with greater muscle mass will go farther. Newton describes exactly how movement occurs in his third law of motion. He states for every action there is an equal and opposite reaction. In swimming, whenever you pull the water down your side for a stroke, you are pushed forward. Griffin will demonstrate this for us while standing up, and then he'll swim a lap to show how his stroke pushes him forward. Whenever Griffin pulls his arm by making a stroke, that is his action. In turn, he gets an opposite reaction, which in this case would be being pushed forward.
Rock and roll!
Overall, swimming has been a big part of my life for a long time, and applying simple physics principles to it can increase a swimmer's speed, explain why some can swim faster than others, and finally show us exactly how this movement occurs in the first place. My name's Annie Bell, and as Dory from Finding Nemo would say, just keep swimming.
Hello again to all my friends, together we can play some rock and roll. Hello again to all my friends, together we can play some rock and roll.